Good afternoon, everyone. Thanks, Tim, for introduction. I'm Qian from IMIT. I'm teaching GIS. So I want to get a quick survey. How many of you get GIS degree from university? Would you like to hands up? Thank you. Obviously, not many of you get GIS degree in this kind of cohort. So that is actually, I'm trying to focus on last couple of years, teaching GIS students to learn development. So my topic is about scaffolded project-based learning in open source cloud GIS. So with 3 case studies developing responsive virtual flooding digital twins. So it's a little bit of change for the topic because one of the presenter, Ryan Turner, was presenting in Perth 2 weeks ago. Some of you already watched his presentation on developing responsive digital twin for flooding. However, today I will cover more on how I actually structured this kind of project into tertiary education to teaching students to developing open source cloud-based GIS. So quickly acknowledge the 3 students who contributed to 3 case studies, which I will show in the later slides. So I will touch on quickly, from my understanding as a researcher, what is exactly cloud-based open source GIS? Why I consider it to be an emerging paradigm, and why I think I need to teach developing cloud-based open source GIS in tertiary education. And how I can achieve that, I developed this kind of pedagogical framework called scaffolded project-based learning theory. And the idea is to develop students' skill from a tool user to tool builders. So I will showcase 3 case studies which my students actually used this kind of paradigm, this kind of framework. They actually implemented their individual projects in one of my classes, and they developed real-world case studies using open source cloud-based GIS solutions. Okay, so what is exactly cloud-based open source GIS? So we've been listening to a lot of awesome talks from the earlier keynote speaking and Tara Jess. I'm definitely used you, they already left, in my teaching. And I probably think to engage more Tara Jess in the new semester in 2025. Okay, so what is open source cloud-based GIS? Right, so when we talk about cloud-based GIS, so the first thing I'm teaching my students to think about cloud. So we have the cloud computing services. Students, they learn what are the services we consider to be cloud computing. So how we can actually use these services in GIS, right? So we consider, so that's the services on cloud. When we talk about the GIS as services, so on the right of the slide, we talk about in the last 30 years, the development of web GIS, including cloud GIS. There's a lot of new technology and a lot of new tools we can use. However, how we can use these cloud services, take advantage of that in new GIS teaching, and why we need to use open source, or what are the advantages of use open source GIS, and how we can put them together to teaching new GIS students in the university. Right, so the students, they learn some basic concepts or theories on the interoperability is one of the key words of the cloud GIS, and accessibility, why we need to use web GIS as a front end, as the dissemination of the GIS project. And of course, we talk about the cost effectiveness as one of the advantages of cloud-based open source GIS. Right, so in teaching, so how can we, engage a lot of theories, concepts, a lot of tools, like tools developed by QGIS, by TerraJS system, into a student's learning. So we engage kind of this framework to put the conceptually a project that we can separate into different layers. So we call it three-tier architecture. Not sure how many of you from computer science background. So three-tier architecture, typically the cloud computing services, they actually distributed or split a typical system development into three parts, right? As we know, there's a data layer, there's an application layer, and a user layer interface. Or in other words, we have the front end and the back end. So in my teaching, I realized it's quite critical for students to understand this kind of framework or architecture. So like the scaffolding, they needed to understand the breakdown individual component of this system development. Right, so then what kind of tools they can use to implement this kind of framework in the three-tier architecture. So of course, there's a lot of open source tools we can use, a lot of open source data we can use, that including start from QGIS, GeoServer, PostGIS, and of course, the OpenLayer and CSOM, Leaflet. There are so many tools we can use. Right, so in my teaching, the students learn this kind of theory concept that they understand the three-tier architecture. They learn to develop their own blueprint to kind of start their individual project. So everyone in the class, they started to build this simple kind of diagram to put together the three-tier components and the tools they can use. Then start build on the database in PostGIS. There are a couple of examples from the students in the class, and they kind of define a real-world problem, then engage this kind of framework and this kind of three-tier architecture to implement their individual project. And during the semester, they were able to learn from the tutors and work with others as like scaffolding project-based individual project learning journey. Right, so next I'm going to show you a couple of examples. The first one is developing responsive digital twin for real-time flood modeling. This one is very successful individual project that use this kind of framework, and it is being published in the ISPIS annals. And start by the student define a real-world problem. Of course, we are aware of for example, the 2022 Mont Blanc flooding in Victoria, and this increasing frequency and the intensity of this kind of natural disaster in Australia. So, and there's increasing literature and industry as well are using this so-called this kind of concept of spatial digital twin. So spatial digital twin technology is a really kind of good framework to tackling this kind of flooding issue. So over the past 20 years, a lot of technology being advanced. For example, 3D mapping, sensors connection, sensors on river, sensors on weather station, so which we can actually monitoring real-time rainfall and the real-time river level. So due to this kind of digital twins advantages, the digital twin for flooding is really a good logic to start to implement this kind of open source cloud-based GIS project. And so for this individual project, the students started to conceptualize what is exactly a spatial digital twin and how we can actually link the physical world to the virtual world. So digital twin is not simply just a 3D mapping. It's not simply just a virtual environment. We can see 3D, a lot of data rendering on 3D environment with interactions at the web. So implemented, a spatial digital twin should be a link between the reality and the virtual world or digital environment. And the linking between these two components should be live data. In this case, for the flooding, ideally the live Internet of Things sensor connecting to, for example, the river condition, the weather condition. And at this point, we still can't call it implement the digital twin until we can provide the feedback back to the reality to help planners, to help the city council officials to make a decision. So close the loop, conceptually, we can call this kind of system a digital twin. And in this case, if we use a real-time flooding data access to the census data, we call it responsive flooding digital twin. So this is the conceptual framework this student developed for this individual project. Right, so to answer the main aim of this kind of project, to tackle the real-world problem, break down into 3 research questions. The first one, how can actually IoT sensor data be effectively integrated into a responsive digital twin technical architecture to enable real-time flooding modeling? So that's the key for a spatial digital twin. And what are the key indicators or parameters necessary to effectively model the flood extent in a responsive digital twin system? And finally, how can this kind of responsive digital twin technology be used to quantify impact of flood event for a real time? So we choose the Morning Valley City Council and the Mont Blanc City Council a study area because they share the river called the Mont Blanc River. And in 2022, there was a flooding event, a lot of damage for local residents. So the data collection including 2 parts. One is the traditional GIS model including the static data for the DEM. During the time when the student developed this program, we only used the 10 meter. Currently, we actually updating this kind of system, use 1 meter DM. And our OSM data and some council and the government data as well from DTP, DECA, Victoria. And the key parts for this system is the live data, which is the last 24 hours weather station rainfall data, which we used as a threshold to determine the flooding modeling, and the real time for the water level census collection, which is published on API we accessed from Melbourne Water. Right, so from the conceptual framework, so this student work with the teaching team actually developing this technical architecture, including the 3-tier component and implemented through the PostGIS created database and use FME to convert a lot of data set into 3D CTDB, which is enable the semantic data modeling. And we use, in this case, we actually use the system to implement the model, use TurfGIS to implement a simple flooding modeling, and use GitHub to host the system as the public URL link. Right, so to summarize, there's a few steps for the technical implement. So we, of course, use a lot of GIS plugins and use QGIS to processing the data, and use PostGIS to create a 3D CTDB, which is a main database. And we access the mapping water API provided 24/7 live data via the radio waves. So, and finally, all these elements put into system platform, use TurfJS to kind of calculate the flood extent and disseminate the interface and publish it on GitHub. Right, so, okay, let's quickly look at some demo. So that is the system look like. I am confident call it open source cloud-based GIS, which we use all the open source tools as I described earlier. And we implemented the 3-tier architecture and use open source tool data as well. So this tool, so as we see in the video, if we click, so we also developed kind of few interaction tools. If we click feature live data, and we don't see the flooding because the water level and the what is it called? The rainfall not reach the threshold in the modeling. So for the demo purpose, we actually change the water level and the rainfall in the back end. You can see on the right side, this water level and the rainfall amount being changed, and then we can see the flood, right? And there are a few slides showing where are the weather stations and how we featured the live data from the weather station and the water level sensors, right? How we actually modify the back end, the water level, the live data to demo or visualize the flood event. So I'm quickly go through these slides to summarize this use case. So the students build from using QGIS to build the database, PostGIS. Then they learn how to integrate those data into system platform. They also learned use API to disseminate the real-time data onto this 3D platform. They also actually learned how to upload all this information onto the virtual platform, the cloud platform. Yeah, although this kind of project limitations is as an individual student project, but this opens for a lot of future research and for us to actually develop mature spatial digital twin as example for this flooding, for heat, for a lot of climate-related kind of digital twin. So, just adding one more thing, so that is not the end of the project. Another student built on that, link everything, bring everything to game engine. So, quickly show last slide. Right, so kind of bring what the earlier responsive digital twin onto game engine. So, and we use VR, enable the virtual reality access to this kind of platform. That opens a lot of opportunity for stakeholder engagement. Right, at this point, I would like to finish my presentation, but I'm very keen to hear from you, give my suggestions, how I can better teaching students in the university to for more engaged in this kind of open source, FOSS4G community, and learn from you guys. So in one Chinese saying, if you want to teach students, build a ship. So what we want to teach them? Let them to imagine an ocean. So imagine if they all kind of looking at you guys' development and your project and your expertise, they would like to learn more into cloud-based open source GIS. With that, I close my presentation. Thank you.
Thank you very much. You can stay there just in case we've got any questions for you to answer as well. Just say it. We've got any questions for Qian.
I also have my LinkedIn. Oh, that's another video, no time to present. So feel free to connect with me on LinkedIn. Oh. So I have LinkedIn. Oh, this one. Yeah.
Thank you very much for your very good discussion on that. Fluid dynamics, and the Maribyrnong is fairly wavy and ends up in a tidal system.
Yeah.
How did you do any work on that?
It's really, really a good question. So a little bit confidential, the students trying to come back to further develop that kind of system with even some runoff modeling. So in this project, we only use the built-in model in TurfGIS, which, if I am correct, is called HackRes flood modeling. So that's a very basic terrain-based model without including tidal and even underlying pipe system. So that's something we're trying to improve. Thank you for the question.
Any other questions? No, please join me again in thanking Qian.
Thank you.